an example number 2 on graphing higher order polynomial functions. Now we have a function f of x equals 3x to the 4th minus 4x cubed. This is what we call a quartic function because the degree is 4. So you probably remember from Algebra 2, the shape of this function could be either a W or an M, depending on the leading coefficient test and its end behavior. So let's take step 1, find the end behavior using the leading coefficient test. Our n, our degree, is 4, which is even, and our leading coefficient is a positive number greater than 0. What that means then is for the leading coefficient test, it's going to rise on the left and rise on the right. So that means for our choice up here, it has to be the shape of a W. Step 2, let's find the zeros of the function so we can find those x-intercepts. So our function is f of x equals 3x to the 4th minus 4x cubed. We want to set that factor equal to 0 and solve for x. So we set the function equal to 0, solve for x. Use our factoring methods that we've learned. Number 1 rule is to see if we can find the GCF. And the GCF in this case is an x cubed. We're dividing out an x cubed. We're left with 3x minus 4. Now I'm going to set the factors equal to 0 and solve for x. So I have a factor at x cubed. X cubed equals 0. Then I have another one at 3x minus 4 equals 0. These are called the zero product property, and then you solve for x. Now, notice the multiplicity of that x cubed. This means that you have a repeated 0. The multiplicity is 3, which is odd. What that means then is that is going to cross the x-axis. All right, let's go on to 3x minus 4 equals 0. Using that zero product property, let's solve it for x. So add 4 to both sides, and then divide both sides by 3. So our zeros of the function are 0 and 4/3. Step 3, identify the x-intercepts of the graph. They are the zeros of the function. So we just talked about, we have a repeated 0 at 0. So our first ordered pair is 0, 0, which will cross the x-axis. And then we have another x-intercept at 4/3, which, if you remember, 4/3 is like 1.3 repeating. Step 4 is identify if this function has any symmetry. So you could test for that. Replace that y with a negative. So negative y equals 3x to the 4th minus 4x cubed. We do not get the original function back. To test for y-axis symmetry, replace the x with a negative. So y equals 3. Replace the x with a negative. Replace the x with a negative. Simplify that. We don't get the original function back. So far, no symmetry. Last test is replace the x and the y with a negative. When you simplify it, you do not get the original back. So no symmetry here with the x, y, or origin. I saved us a little bit of time, and I found some additional points already around those intercepts. Here's one of the intercepts on the x-axis. Here's the other x-intercept. What we talked about, it was a repeated zero, and it will cross the x-axis. And then I just went out and found a few more additional points by evaluating the function. So I'm just saving us some time. Now let's go on and graph those pieces. So let's start with the x-intercepts. The x-intercepts are 0, 0, and 4/3 0. So I'm just going to kind of stretch out this graph a little bit. I'm going to call this 1, 2, and 3. 1, 2, 3. So I'm scaling it by 2. All right. We have order pair at 0, 0. And then another one at 4/3, which is 1/3. 1 and 1/3 right there. Now let's talk about the end behavior. If you remember end behavior from our leading coefficient test, up here, we're going to rise on the left-hand side and rise on the right-hand side. So we look at those x-intercepts. We're going to rise on this side, and we're going to rise on this side. So we go to those x-intercepts, and we're going to graph up and up. Then look at your repeated zero. This repeated zero crosses the x-axis, so it must come down. And then what happens is we have a few more additional points that give us that little W shape. And I'll let you kind of graph that with these ordered pairs. -1, 7, -1, -1, and 1.5, 1.68. Those are the 3 additional points.